Okay, so implementing static root. So router are the devices that connect multiple network. Okay, and those network are either directly connected to the router or they're connected to another router. Okay, so there are directly connected route and there are remote route. Now if you look at R1, it's connected to how many network? Can somebody tell me how many networks is connected to? 1, 2, 10, 11, and this one, 209.165.200.24. Okay. So the network, so if PC1 wants to access PC10, the router will route the packet directly to PC10 because it's directly connected. Okay. But if PC1 wants to access PC3, the router need to know about this network. Why? Because it's not directly connected. It's remote network. So there in the router's routing table, initially there are only directly connected route or directly connected network. Router does not, so for example here, R1 does not know about this network, 10.11.0, which is connected to R2. So R1 does not know. So PC1, if there's no routing table entry in R1 about this network, PC1 cannot access PC3. Okay, so this is one of the configuration of router. This is the job of anybody who's configuring router, to create routing table. Okay, and creating routing table is telling the router what network is not connected to the router and what networks are actually the remote network. So in R2, what networks are not directly connected? So R2 need to know what network. In R2 routing table, what network you should be adding? Anybody? Just look at the topology, okay? So this is the key of creating a static route. You look at the topology and you look at what networks are not directly connected. Okay. So there are two ways. So the routers need to know about the remote network. Okay. There are two ways, and that information is in the routing table. So there are two ways to create routing table, either manually, okay, manually entering route in the route into the routing table with the command, or use a routing protocol, which is a software, okay, that will create the routing table automatically. So this is called dynamic routing. Either create a route manually with the command or use a routing protocol that will create the routing table automatically. Okay, so that's what we're gonna do here. Now, what are the different? So, which type of routing you should use? Either dynamic or static. Well, static looks like more work because you have to do it manually, and dynamic looks like less work because it creates a routing table automatically. So is it dynamic better than static? Because you have to do less work? Not necessarily. Okay, depending on the situation. In a large network, you have to use dynamic routing because it's impossible to create any protocol, sorry, static route. For example, Bell network has hundreds of thousands of different network. It's impossible to create a static route on each router. So in a large network, it's you have to use dynamic routing. In a small network, you can use static routing. Now, the advantage of static routing, because it uses less resources of the router, of the device. For example, it uses less memory, it uses less CPU power. So it's faster. So in a small network, and dynamic routing uses memory, uses, because it's a software, it uses memory, it uses CPU power. So it's a little bit slower than static routing. So, excuse me. So, in a small network, it's better to use static routing. Okay. Also, with static routing, if something goes wrong, so if you look at this topology, if for example, if this link G000 goes down, okay, so this route is no longer available. So what you have to do is you have to remove this route from the routing table manually. So in a small network, it's not a big deal. But even if you have a large network, you have to go to each router and remove that route manually. That's a lot of work, and sometimes you're not available, okay, to remove that route. Because if you don't remove that route, your router keeps sending the packet to that network, and that network is not available. So it can create a problem on the network. It can bring down the network or slow down the network. So you have to be able to fix this problem, either fix the interface, but first thing you need to do is you have to remove the route. So if you're creating a static route, if you're using a static routing, that could take a lot of work if you have many network. In dynamic routing, it will be removed automatically by routing protocol. So that's another advantage of dynamic routing. If there's a problem on the network, it will self-correct. Okay. Now, so that's the major difference between dynamic and static routing. Okay. So which one you have to you should choose based on your topology, based on network. Okay. When to use a static route, smaller. So these are the three commonly static routes are used in these three type of network. Smaller networks that are not expected to grow, so you can use a static routing to and from a stub network. A stub network is a network that accessed by a single route that has no neighbors. So if you see, this is the stub network. It has no other network connected to it. Okay. So you can use static routing on a stub network. Or you can create a default route to a single network. So for example, if your router, this router is only connected to the internet, right? And there's no other network that is connected to. So then you can create a static default route to send your packets to the internet, and usually this default route is the address of the ISP. Also, you can create a static route as a backup route in case one dynamic route fails. You can create a static route, and it obviously it's connect to a specific network. So here you have R2 router. R2 router does not know about 172.16.13 3.0 network. Okay, So you can create an entry on R2 router, and this entry, so it will tell R2 router that this network 172.116.3.0 is connected to R1. Okay, because it's not directly connected to R2. Okay, so this is how router works. When router receive a packet, it look at the destination address in the packet. Remember, every packet has source and the destination IP address. So when router receives a packet, it look at the destination address, destination IP address, and then it matches the destination IP address to the entries in its routing table. Okay, to see where to forward this packet. Okay, where this network is located. Now, is it possible to add all the networks in the world in one routing table? No, it's not possible. Like, for example, your router at home does not have the entries of all the network in the world. Okay, so how do you access the internet? How do you access Google? How do you access Facebook? How do you access whatever the Cisco site? Because if the routers does not find the destination address in its routing table, it discard the packet. Okay, it will not forward it. It will just discard the packet. So you will not able to go further. Now, how your router is able to forward packets to the internet? By using default route. Okay, default route uses 000 as the IP address, and 000 for the subnet mask. They're called wildcard, meaning 40 means all the network and 40 means all the subnet. Okay, so if your router is connected to the internet, your router is also has a default route entry in it, and we will talk about how to create a default route later. Right now, just try to understand what is the purpose of the default route. Okay, so default route is created on a router that is connected to the internet. Okay, and so if your router is connected to the default route, it will look at the destination address in the packet, match with the IP address, match the destination address to the address in routing table. If it does not find the match, it will send, instead of discarding the packet, it will send that packet to the ISP router. Okay, that's how you are able to access to the internet. So in your home router, there is a default route. That's why you can access the internet. That's how you access the internet. That your router send the packet. So if you're typing www.cisco.com, your router will send the packet to your ISP router. So this is what that's what the default route is. And it's also called, the default route is also called gateway of last resort. So remember, they're the same thing, gateway of last resort and the default route. Okay. Okay, so instead, a summary route, we're not gonna create summary route in this course. This is more advanced. So those of you who are planning to pursue CCNA, maybe you will need to do this later on, but at this time, we're not gonna actually create the summary route, but it's good to know what a summary route is. So a summary route is a route that combines the multiple network that uses the same subnet mask. As you can see, there are one, two, three, four network. They uses the same subnet mask. They start from 172.21.0.0, 23, 22. So you see they're very identical. They use the same subnet mask. So instead of creating four entries, the router just creates one entry, meaning it summarizes these four network to just one network. What is the purpose of this? It's just make the routing faster. Okay, it's the router algorithm that uses it to improve the performance of the routing. This is called the summary route. Floating static route is a route that is used as a backup. It provides the backup path. So here you can see branch and HQ are connected. Instead of just one link between branch and HQ, there are two links. One from S000 to S000, and the other one is using S001 to S000, is to provide redundancy in case, because probably there are very important, maybe the database server is on a HQ, right? So the users in branch should always have an access to that database server. So in case one link goes down, the other link is still up. So this is a backup route. So one is the private WAN, private link, the other one is through internet. Well, any link through internet is less secure, so this is the primary link. This is just as a backup. So once this link is up, then this will be used as the primary link. All right, so now how do you configure the static and default route? Again, the command is Iproot, and then you have to provide the network address and the subnet mask. Network address, what network address you need here is the network that is not directly connected. Okay, so any network that is not directly connected, you have to specify it. That's the first thing. And the second here, IP address or exit interface, is how to get to that network. Okay, what interface will be used to get to the network. So let's take the example of this here. Oh. All right, so you guys have to work with me here. So if you're configuring R1, how do I zoom in? Can you guys see the slide?
It's too small.
Okay, hold on a second. This is still small, right?
Yes.
Okay, so anyway, this is the, I cannot do better than this. All right, so here R2, so R1 is, so first rule is to identify which network is not directly connected to your router. So if you're configuring R1, so if you look at the topology, you see 3.0 is directly connected to R1 and 2.0 is also directly connected to R1. Okay. The network that are not directly connected to R1 is R1.0 and 2.0. So we have to tell R1 about these two networks. Okay. Now, if we go to R2, which networks are not directly connected to R2? Can somebody tell me which networks are not directly connected to R2?
192.168.2.0 and 3.0.
So 192.168.2.0 and 192.168.3.0. So we have to tell R2 about these two network. Okay. Now, if you go to R3, what network are not directly connected to R3? 172.16.3.0 and 172.16.1.0. So we have to configure all these three routers with static root. Okay. So show IP root, you see here when you type show IP root on R1, you only see directly connected root 2.0 and 3.0. You don't see 1.0 and 2.0. So we have to configure it. Now, the command is IP root. Okay, so we are on R1 IP root, and we specify the network that are not directly connected. So it's 172.16.1.0 with the subnet mask 2550. And how to get to this network? We get to this network through R2 interface. So R1 is connected to S000 on R2. And what is the IP address of R2? S000 172.16.2.2. So the exit interface is 172.16.2.2. So the rule is the IP address of the router that is connected to, not your own address. The IP address of this interface is 172.16.2.1, but you have to specify the IP address of the address that your router is connected to.
Can I ask a question?
Sure, go ahead.
Can I skip the second line? And if yes, what would or if not, why not? The second line of IP root 192.168.1, the second line. Can I skip it?
No, you can't, because then your router would not know about this
Yeah, but
network.
I'm not trying to. There's nothing for me there. In that network, there is nothing for me there. There is no computer I want to reach in this particular network. Why do I need it?
Oh, because this, in order to reach this network, right?
Yeah.
In order to reach this network, it has to go through this network.
So it needs to know all the networks on the way to the last one.
Exactly.
Okay, thank you.
Okay, so now after, so the rule, always remember, just count all the network that you have okay, that are not directly connected and added to the routing table. So the next network is not directly connected, even though there's no computer is connected to it, but you have to still specify, okay? So 192.168.1.0, okay, is the network, and how to get there is the same interface, 172.16.2.2, okay? Other network, 192.168.2.0, is also the same interface. So the packet will, so if PC1 is accessing PC3, the packet will start from here, will go to the router, and it will exit the router and go to the R2's 172.16.2.2 interface. So it's the same path, okay? So this is how you create a static root. Very simple. Iproot is the command and the next hop IP address, okay? Now, the next hop, instead of us specifying the next hop interface, the IP address of the interface, you can assign here. If you look at here, instead, you can assign the name of the interface. So there are two ways to choose the next hop. Either specify the IP address of the router, or assign or use the name of the interface. So you see it's S000. So instead of IP address, you can just use the name of the interface. But if you're using the name of the interface, it has to be your own interface, not the next hop. So remember, if you're using the IP address, you're using the IP address of the next hop. If you're using the name of the interface, you use the name of your own interface. So for example, if it was connected, R1 is connected to R2, R1 is S00, and R2 is S001 instead of S00, and you're using the interface name. So you will use S00, not S001. Okay, so remember that if you're using the next hop IP address, it should be, sorry, if you're using the IP address, it should be the next hop IP address. If you're using the interface name, it should be your own interface. A fully specified static route. So here you see a fully specified static route uses both the name of the interface and the IP address as well. Okay. So if the exit interface is Ethernet, so for example, here you see is G0. In previous example, it was serial. Here is the serial interface S0, okay? But if the interface is Ethernet, G0, if the routers are connected with Ethernet interface, it's better to use fully specified static route, meaning use both the interface ID and the next hop IP address. Why? Because Ethernet uses broadcast. Okay. No, it's not because of broadcast. Sorry. But with Ethernet interface, the routing is much faster if you use both. The name of the interface and the IP address. But it can also work if you only use just the name of the interface or the IP address. Okay, it will work, but it's best practice to use both on an Ethernet interface. It's recommended by Cisco. Okay, so once you configure the static routing, well, you should there are commands to verify your routing table. One of the command is show IP root. Okay, so it will show you the list of it will show you your routing table. It will show you all the routes that that are configured. Okay, you can have both dynamic and static routing configured in your router. So show IP root will show everything, but you can be more specific. So if you just want to see your static route, you type show IP root static begin gateway, and it will only give you the list of static route in your routing table. Okay, you can also check a specific route, just one route. Type show IP route 192.168.2.1 in case you don't see the user cannot reach this network and you're trying to troubleshoot. Probably the problem is related to routing, so you can see the specific route. Okay, and you can also verify static route in your running configuration. Everything is in your running configuration. Okay, but running configuration can be very, very long, so you can type show running config section IP root, so you filter the result by using, but the best way to verify your IP root is typing show IP root. Okay. Now, in the default static route, very easy. So instead of the destination IP address and the subnet mask, okay, you type this. This is called wildcard mask. They are wildcard. 0 represent a number, okay, but it means any network. And this 0 for the subnet mark, same thing, any network, any subnet mask. So 00040 represent 4 octet in the IP address. A lot of people make this mistake when they're creating the default route. They don't leave the space here. Okay, so be careful when you're creating a static route. There's a space between these 4 zeros. So 000 represents an IP address, space, these 40 represents a subnet mask. And then the exit interface, either IP address, next hop IP address, or the exit interface. So it's the same thing. Very easy. You create a static route, a default route, mostly in a router that is connected to the internet. But actually, if you have an internet connection, you have to create the default route in each router. So let's see, any packets not matching route entries are forwarded to 172.16.2.2. So on R1, instead of creating another another use of the default route, instead of creating, before we created how many routes? 192.168.1.0, 2.0, and 172.16.1.0. We created 3 entries, right, on R1. But instead of creating these 3 entries, we can just create one default route on R1, and it will send every packet. So if PC1 wants to access PC3, your R1 will send the packet to R2. Okay, then R2 will take care of it. Okay, what else? If PC1 wants to access PC2, the same thing. Your R1 will look at the destination address. It will not find the match because It doesn't have the entry of 172.16.1.0, so it will send the packet to R2 because there is a default route. And to verify the static default route, type show IP route is static, and it will appear as with S and asterisk. That's the default route 000 via 172.16.2.2. Okay. So this is how you can verify your default route configuration. Okay, as IP, as everything else, the difference between IP version 6 and IP version 4 is you type IP version 6 address. Otherwise, the concept is the same. So the command is, instead of IP root, here is IP root. For IP version 6 is IP version 6 route, and then the network ID that is not connected and how to get there, either IP version 6 address of the next hop or the exit interface. Same thing, nothing different. So here is the same network. Instead of using IP version 4, it's using IP version 6. Okay. So the first thing you have to do is you have to enable IP version 6 routing. Okay. By default, it's not enabled. Okay. So you have to enable IP version 6 routing. You have to use this command. Okay. And then you just like IP version 4, just like IP version 4. So here you have R1, same topology. Instead of using IP version 4, it's using IP version 6, and it's the same concept. So the command is, you have to specify v6. So IPv6 route, okay. The network ID 200.2ba2.64, which is this one, which is not directly connected. So that's the network, and the address, IPv6 address of the next hop here, R2 4 dot. So this is the network, and 4.2, and same thing. So another network is 5. Okay. So you specify that network, how to get there with this IP address 4.2. Same thing, another network is 3, which is this. You specify this network and how to get there with this through this interface, next hop, and that's the IP address. Or you can only specify is connected to S000. That's also, instead of this IP address, you can just type S000. So in IP version 6, you can also specify fully specified static. You can also configure fully specified IP route by using both the interface ID, okay, and the next hop IP address. You see, this is the fully qualified route that is using both the interface ID and the IP address of the next hop interface. To verify IP version 6 static route, the command is show IPv6 route. Show IPv6 route. This is how you verify the specific route, and you can also see running configuration, the section of IP route in this running configuration by using this command, by filtering the command. Okay. A default specific route is everything else is takes longer in IP version 6 to configure compared to IP version 4, but the default route is much easier. So IP version 6 route colon that represents all the network /0 all the subnets. So that's it. It's much easier to configure a default route in IP version 6. IP route is the command colon /0, meaning all the network. So here's the default route, IP version 6 route colon 0, and this is the how to get there. This is the address of the next hop, 4.4 colon 2. So this is the network, and this is the address assigned to R2. Okay. And here the commands are the same. How to verify default static route, show IP version 6 route is static. And you see here, S represents a static route here, S. So that means, so if you configure a static route and you're having problem accessing the network, you can verify if the static route is default static route is configured properly. Floating static route. So I already explained a floating static route is a backup route, and it used if in case a link goes down. Okay. So you can test so if you configure, so we have one more class in the school, and you can also do it on Packet Tracer. Okay, remember, any lab that you can do with real devices, you can also do with Packet Tracer. Okay. So for example, once you create a floating static route, for example, there are two links that connects two devices. Just shut down one link by using no shutdown command in order to test to see if the other link is still live, meaning it's still carrying traffic for your network. Okay, somebody asked me, always people get confused in the beginning when they see an IP address with 32-bit subnet mask, okay? Or in IP version 4, 182-bit subnet mask. So if you type show IP route, here you will see L. C is the network ID, and L you see is the interface ID. Routing table, routing algorithm use this to route packets or also to identify which interface is being used to route this specific network. So 192.168.51.100.0 is the network, and 192.168.51.100.1 is the IP address of the interface that this network is connected to. So which is serial 000, okay? And it says it's directly connected. And it uses all 32 bits as the subnet mask. And don't ask me the reason why. There's a mathematical reason, which we don't need to be concerned. So once you configure static and default route, how to troubleshoot? Same commands: ping, trace route, show IP route, show IP interface brief. Maybe the IP address is not assigned correctly on the interface. Maybe the interface is down. Also, remember the command cdp neighbors. Yes, you can also use that command. So all these commands you can use. So if PC1 cannot access PC3, ping your default gateway. Okay. If that works, then use traceroute command. Maybe the problem is R with the R2 or R3. Okay. If it doesn't go through, if it is stop at R2, now you have to find out what's wrong with R2. Go to R1 and type show IP route to see if this network entry is there in your routing table. If it's there, then go to R2 and see if it's configured properly. Okay. Type show interface brief. So if the routing entry is there, and so what could be the other issue? Maybe something wrong with the interface. Okay, so you type show IP interface brief to see if the interface is up or down, or the IP address is configured properly. Okay, if the route is missing, what could happen is because you did not configure it. So the type show IP interface brief, IP route, okay, show CDP neighbors to verify. Most of the connectivity problem are related to mismatch IP addresses. Maybe it's not in the same subnet. If you configure R1 and R2 IP address, maybe 170, and the network between those two routers is 172.16.2.0, right? So they both have to be in the same subnet. Okay, so check they're in the same subnet, and check for the cable as well. All right, guys, so that's the end of chapter summary. Okay,